given, we know that it's continuous as a polynomial function and it's differentiable on at least 0, 2. It's differentiable everywhere, but at least on the interval, open interval 0, 2. By MVT, there exists a C in this interval such that this happens. First, I have to find f prime of x, and this is 4x minus 3. That will be the left-hand side, 4c minus 3 in this equation. Now I have to find f of 2. So f of 2 is 8 minus 6 plus 1. 4 times 2 is 8, minus 6 plus 1. 9 minus 6 is 3. So this is 3. F of 0 is 1, and 2 minus 0 is 2. So then 4c minus 3 equals 2 over 2, which is 1. Nice. 4c equals 4, c equals 1. And it has to be in the interval 0, 2. At least 1 c. Guaranteed by the mean value theorem. Now the other one, we are given f of x equals natural log x, and the interval is 1, 6. All the same. So number 1, f continuous. So continuous function anywhere on 0 to infinity. On 1, 6 in this case, because that's all we need. And f differentiable on 1, 6. Again, by MVT, there exists a C in the open interval 1, 6, such that f prime of C equals f of 6 minus f of 1 over 6 minus 1. And like before, I have to find first f prime of x, which is 1 over x. In this case is 1 over c on the left hand side. F of 6, I don't know, it's just natural log 6. F of 1 is 0, and 6 minus 1 is 5. I flip both, so c equals 5 over natural log 6. Just to make sure, it has to be in the interval 1, 6, but just to make sure, I'm going to double check, make sure I didn't make an error. 6 divided by natural log 6, not 6, 5 divided by natural log 6, and it's 2.79, which is in the interval 1, 6. Okay, moving on. I want you to have a boost on all these so you can finish them in this week if possible. So we can review again maybe next Monday. Okay, so let's move on to 4.3, 4.4 graphs, or directly graphing 4.5. You do not have to worry about 4.6. So 4.6, there is no need for you to do anything. So you only have 4.1 through 4.8 minus 4.6. Okay, so what do we continue with? We have Newton's method, optimization, graphing. Newton's method of optimization, graphing, and L'Hopital's rule.
Would we do some optimization and
yes, optimization and
Newton's method.
Okay, very good. So let's jump to 4.7.
Like, I don't know, there's, like, unless anyone else has something else to do, but
Okay, you want me to choose?
yeah.
We did the poster problem. We did yeah, why not? Let's do that piece. We haven't done one with a piece of wire. Yeah, let's do 11. Unless you want to choose. If you'd like to choose, I'll wait.
No, that's totally fine.
Okay, 11. So we have a piece of wire that is 8 meters long, they say, and it's cut into 2 pieces. Okay, let's say we cut it here. One piece is bent into a square, and the other one is bent into a circle. How much wire should be used for the square in order to maximize the total area? How much wire, that's part A. How much wire should be used for the square in order to minimize the total area? Okay. So we basically want to find the maximum area and the minimum total area. Okay. So total area, and we want in part A, find the max, in part B, the min. But we have to be careful how we answer it, so we'll get there. Okay, so I'm going to denote this by x, 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 and obviously this piece must be 4x. The circumference of the circle is 2 pi r, and this is 2 pi r. So for now I know that 8 meters must equal 4x plus 2 pi r. So leave that alone for a moment. And now let's create the total area. Any questions so far? Are you with me, everyone?
Yep.
Okay. So the total area will be composed of the area of the square and the area of the circle. So the total area, let's say total area, is base times height, or just side squared, plus pi r squared, which is the area of the circle. Well, like before, we need to get rid of something, because I can differentiate a function of 2 variables. So it's either we solve this, I should have not put the meter here, I'm sorry. There is no need in an equation. So we either solve for x and plug it in and square it, or we solve this for r and plug it in and square it, to make the total area function of one variable. Okay, so I don't know. I'm gonna, let's say, first of all, I'll divide both sides by 2, and I get 4 equals 2x plus pi r. A divided by 2, 4 divided by 2, and this. Do I want to divide by pi? I'm not sure. That doesn't matter really. So 4 minus 2x divided by pi is r. This is going to replace r. I have to square it. And now I get the area, which is indeed a function of one variable. First part is x squared plus pi times pi squared in the denominator and this squared. 1 pi goes away. So the simplified form for now anyway is this. Plus 1 over pi 4 minus 2x squared. So whatever I get, it's okay. I do have the function now, and I need to differentiate and find critical numbers. It's a quadratic function, so we'll see. It can have more than one, but we'll analyze it in a minute. So a prime equals 2x plus 1 over pi, bring down 2, subtract 1 from the power, and multiply, and in parentheses, by -2. The inner function prime. Okay, let's see what else we can do here. 2x minus 4 over pi times 4 and plus 4 over pi times 2x. So I have a negative 4 over pi distributed to 4 and negative 4 over pi distributed to negative 2x. That's why this changes into positive. Okay, so now a prime again is, if I factor, so 2x plus 8 over pi x minus 16 over pi. I have to set this equal to 0. And I get, I will write it first like this. And then I have 2x plus 8x over pi equals 16 over pi. I can eliminate pi by multiplying everything by pi. So I have 2 pi x plus 8x equals 16. I still cannot combine them, but I will factor out x. So x equals 16 over 2 pi plus 8, and I can simplify. Not that I can do a lot of damage with that, so that's it. So the critical number is x equals 8 over pi plus 4. Okay. I have to approximate because I have no choice. I don't know. Let's see what they want. How do they want the answer? Let me see. What do they say? They don't say anything. So I still need to at least know what this number is. So 8 divided by, in parentheses, pi plus 4, roughly. About 1.1 approximately. 1.12 meters. Okay. So back to where I was. We determined the critical number for this function. This function, this one. We determined the critical number. So then and the maximum, if this is 8, what can the maximum be? 4x equals 8, so x is 2, maximum possible. So then I have a prime of x and a of x. Okay, I know that this is 0. When I plug in 0 in the function, when I plug in 0, this is 0, this is 0. 4 squared will be 16 over pi. When I plug this in, I have no idea what I get. We'll see in a moment if I need that. And then when I plug in 2, let's see what happens. This is 0. And of course, I get 2 squared, which is 4. Okay. About the sign of the derivative. The sign of the derivative. When I plug in 0, yes, I have negative and then positive. Okay. So I study the sign, I have the derivative, I have, now the question one more time, how much wire should be used for the square? In other words, how long should 4x be to maximize the total area? So, as we see, this will create a minimum. So 16, let me also look and see what 16 over pi is. I just, 16 over pi, just to have an idea, roughly divided by pi. Yeah, so 5.09. Okay, this is approximately 5.09. So from 5.09 it drops to, we can verify what that means, and then it goes up to 4. So the question is, for when x is 0, the area of 0 16 over pi, and this is 0, yes. The area of 0 is 5.09 squared meters. And that means that we use only the entire 8 meters for the circle. So 8 meters for circle. And that is the absolute maximum, according to this. Yes, I know I didn't determine this, but it doesn't matter. Okay, at this point. So when x is 0, and we use the entire 8 meters for the circle, that will give us the absolute maximum, 5.09 square meters. The second part, so this is part A. In the second part, how much wire should be used for the square in order to minimize the area? So now x is, where's my x without approximation? This is my x without approximation. So how much wire should be used for a minimum? So this length is 4 times x. So for part B, 4 times 8 over pi plus 4, which is 32 over pi plus 4 meters, will give an absolute minimum, which I don't have because I didn't calculate. Minimum area. So the problem, the function itself gave us the minimum, and we knew that this was the minimum. We studied the sign, there was no question there. And this number is greater than this, so this must be the absolute max. This must be the absolute min and local min, and this must be nothing. So if x is 0, in other words, we bend the entire wire into a circle, then we get a maximum area. If we are interested in determining the minimum, then 4 times x will be this. 4 times x is the minimum, is the piece that will give us the minimum. Does it make sense?
Yes.
Any questions? Any questions on this problem? Very interesting. Very interesting analysis. I'm getting a sip of water. Very good. Questions?
I couldn't hear you, Derek. I'm sorry.
I'm sorry. Can we do an example of Newton's method?